All right. Sorry.
Sorry.
I stepped on you, I'm sorry. Okay, let's get the handouts going. Here's one. We'll keep it all just one stack because we have others and I don't want to get them confused. There we go. And over there. Actually, no. Let's do two stacks, but please don't get them confused. Usually I do different colors. Go some this way, let that one get ahead. Okay, one of them is clearly the syllabus, the other is a content handout. And then a green sheet. Okay, I don't make a huge number of extras, so if more end up over here, please sort of say, hey, I've got extras over here, maybe somebody over there needs some. Okay, anytime throughout the course. Also, if there's extras, if you'd please bring them down to me. You don't have to do it at the beginning, but at the end of course, sort of just bring them down if someone would be willing to do that if the extras end up with you. Okay? You just bring them down, sit them on the table, say, hey, here they are, or whatever you want. Okay, I would appreciate that. So we got two whites and a green going around. Once we get this out, we'll make a few comments about the syllabus. Comments I make about the syllabus will be very miscellaneous. Okay? One thing you'll find with me if you don't know, I'm not going to sit here to read the syllabus to you. Okay? Anything that's written, I expect you to read and follow and know that it's important. Okay? Because I don't stand up here and point something out doesn't mean it's not critically important. Because if it's clearly written, I expect you to read it. Okay? Hopefully you'll appreciate that, because otherwise, what did he say? I didn't say anything. It's written there very clearly for you to read. If you have questions, please always ask for clarification. As you will see in the syllabus, though, not being aware of what's written is a no-no. Don't ask questions that are clearly in the syllabus, answered in the syllabus. To me, half of this course is organic chemistry. The other half is working on your so-called soft skills. Okay? Learning how to learn. Learning how to be accountable for your learning. Learning how to ask questions in class, outside of class. Learning how to be organized. These soft skills are actually the major components of doing well in this course. Not so much that it's overly difficult material. Actually, the material is a wee bit easier than Organic 1, because Organic 1 we learned all the foundation. And it was brand new to you, and so it was a little bit difficult until you kind of learned it. Organic 2, we reused a lot of that stuff. Okay? We start applying it more. So if you got a good foundation for Organic 1, you're in good shape. If you work hard, and stay organized, and ask questions. And don't let a day go by that you have not focused on organic chemistry, because you're probably going to take this course once in your life. This is it. This is your chance. It starts today. Hopefully you only take it once in your life. But see, it's your only opportunity to have an organized look at the material that's traditionally covered in Organic 2. Okay, next handout. It's kind of a big one. Good. NMR. NMR is a major topic for Test 1. NMR is the most important of the analytical techniques in organic chemistry. Probably the major one we used in Organic 1 was IR. Okay? Now IR, there was a good bit to it. And probably when you started IR, it seemed a little intimidating. But once we got through it and you started, you settled in, was IR overly intimidating? No, not really. There's just a lot of material that has to be covered to get you up to speed. Same thing with NMR. There's actually even more material that has to be covered to get you up to speed. Probably a third of this handout is just illustrations, examples, reference material. It's not all going to be, content to be mastered. Okay. A lot of this is just, okay, let's look at this diagram. Here's an example. Here's an example. All right? But it is a lot. But it's not difficult. Since it's a lot, if you get behind, if you're not organized, then it will become difficult. Okay, NMR. NMR we will cover in lab next week. All right? By the way, I'm not Dr. Agee, I'm Dr. Stevens. Okay? Dr. Agee and I switched. That's why I'm 10 o'clock instead of my preference for 8. Also, instead of my preference for Friday lab, it should be your preference too. We have lab on what? Monday, Tuesday, Wednesday? Okay, and the Tuesday is at what time? Who's Tuesday lab? What time is that lab? Yeah, it's not the traditional 2:30, it's 11. You know what it is. Okay, during lab this week, well, I'll say this week, it's actually next week. Your first lab, we'll check in, and then we will come downstairs. I'll tell you what room, but hopefully this room, and we will have NMR lecture during the lab time. Check in, then NMR lecture. Here's your NMR handout. I also want to send you this perhaps by email, so you have an electronic copy. Some of you I know like to just be able to work, see it on your device or whatnot. I almost sent it yesterday, but I wanted to send also the pre-course worksheet answer key. Okay, everybody got emails about pre-course? Okay, a number of you attended. I want to send out the key to that, but I can't find it right now, so I may have to redo the key, and that's why I'm a little bit late on doing that. So next day or two, I'll send out that, this, a couple others. There will be handouts sent out by email that I expect you to print on your own, and they will not be distributed here. Okay? I'm not going to do that today because we're just getting going, and you may not get my emails. But for example, in the next few days, I'm going to send you probably handouts and have you have printed by, for example, Wednesday. I will always give you plenty of leeway. I'm not going to send you something that night and say, hey, have this printed in the morning. Okay, I'm not going to do that. Okay. I gave you the handouts to get us going today. So always be aware that there could be emails and handouts and emails, and you're expected to print those. Okay, everybody got the 3 handouts. Let's see. I think I got them up here. Yes. Here we go. Okay, syllabus. I'll just show some things here. Everybody knows the Standard Textbook of Record is the book by Klein. Okay, this is the hardback version. In our bookstore, we offer a paperback version. I think it looks like this to save you some money. It's missing a chapter. It's okay. But you can probably get this one cheaper on Amazon than that paperback here. Okay. Also, but if you do buy this one, it does come with the access code for the Wiley system, which gets you the solutions manual, the electronic version of the solutions manual, and you can also have access to the Wiley Plus system where you do homework problems. Okay. I don't deal with that Wiley system. Actually, I don't require homework. Okay. I don't require you to attend. I don't require you to get out of bed in the morning. I assume you attend because you want to be here and you want to learn. You need to be doing homework, but again, you need to be self-motivated to do that. Whatever works for you. Okay. Now, I'll also say on the syllabus, I believe that you can use any textbook really you want. I don't go by the textbook and say, hey, today we're looking at chapter 12.3. Let's look at it. No, I go by topics. Any topic I cover will be in any textbook. Just about. Okay? So, a number of you already have textbooks, hopefully from Organic 1. But just know, if you have a textbook from your cousin who took the course a year ago, then fine, use that textbook. I don't want you to spend $300 for a new textbook. That's a waste of money. Now, some of you may feel uncomfortable about that, and you want to get this book. That's fine, too. Whatever makes you comfortable. And okay. Please have a solutions manual. You need to be working problems. You need to have a solution manual so you can check your answers. Okay? If you don't have a solutions manual, then I fear that you're not going to do well. Okay. You need a book that covers lab techniques. The standard one for this record is the one by Morag, Laboratory Techniques. It's sold in the bookstore. Past editions are fine. There's also one floating around by Zubrick that I may mention somewhere. We used to use the one by Zubrick, and you can find them on like Amazon for a penny plus shipping. Okay. Again, if we're going to do something related to TLC, well, both books have TLC. We discussed that. Okay. It's more important for you to learn the technique and to be prepared for lab, etc. Okay, I also produced my own, what I call Organic Chemistry 2 workbook and lab manual. We had one Organic 1, this is the Organic 2 version. The first half is what I call the workbook, table of contents. There's an overview of what this is about. Table of contents is organized according to tests, test 1, test 2, test 3, and test 4. I give 4 tests in Organic 2. And then there's the answer key section. And then the back half is the lab manual. It starts with like overview to lab safety guidelines, comments on lab notebooks and pre-labs, lab report requirements, checking into and out of lab. There are check-in instructions in the lab manual. You need those instructions for Monday or whenever you come to lab. Okay? There's also the check-in sheet, which you will tear out of the manual there to submit, etc. There's some directions. Then here's our labs. Okay? Note that we are not doing all of these. Okay? Very often I'll have a student come to the first lab ready to do this one. And then they learn we're not doing that one. The labs that we're doing are indicated in the syllabus on the back of the second page. Call this the daily outline. Here we are right here. We'll begin with nomenclature of alcohols. There's no lab this week. Next week, which begins Monday for lab, this is the lab for that week, no matter what day you come. Okay? It's over here. No matter what day you come, we're checking in and then having an NMR lecture. Following week, no lab because of MLK Day. Well, how about you guys on Tuesday or Wednesday? Well, I have to cancel lab the entire week. We may do something by video, or there may be some handout or something to do. That's that. What else is in the syllabus? What is the first lab we are doing? First lab is not to this. It's a reaction of an alcohol with the Lucas reagent. Okay? And it includes, I believe, some NMR, use of NMR. Note there is, some of you may have caught wind of this, a very long 8-week lab, which I do, called the Fluorine Lab. Talk more about it, but it's a single 8-week long lab project. I see at the bottom, the final exam of this course is the ACS standardized exam. Okay. Comprehensive, covers both Organic 1 and 2, 70 multiple choice questions. Okay. Not made out by me, made out by some committee in like Minnesota or somewhere. One of my goals is for you to do very well on that exam. Okay. A number of you will then go on to take like MCAT or DCAT or something, yeah. Okay, and there's an organic section on there. Okay. But that exam holds us all accountable to what organic students around the country are expected to know. Okay? Holds me accountable. I can't just sit up here and talk about 2 things and say, hey, we had a great course. There's many things that need to be covered to prepare you for, example, that exam. Okay. What else is in the syllabus? My background is in drug development. Here are a number of drugs. Many of these you have even taken. For example, Advil. Aromatic. Every one of these drugs has an aromatic benzene ring. And there's other types of aromatics. Test 2 will be aromatic chemistry. Test 1, by the way, is like alcohol, ethers, NMR, and we'll start doing some multi-step synthesis. And epoxide chemistry will be important in test 1. Epoxides. Organic 2 is largely focused around functional groups. You learn in Organic 1, but in Organic 1 we really only deal with like alkenes, alkynes, and we see some functional groups with like substitution reactions. But here we're really going to focus on the functional groups. For example, carboxylic acids, okay, ethers, amides, phenols, okay, amines. I told you test 1 and test 2. Test 3 and 4, both of those are on carbonyl chemistry, like carboxylic acids, ketones, aldehydes, and chemistry of those type compounds, which we saw a number of those on the coffee sheet. What else is here? On the back, Bristol Myers Squibb. Want to get a job one day? This stuff is very practical, okay? Especially lab. I don't particularly like to teach you stuff that is just, okay, let's learn this and then forget about it. I want it to be useful for you, not only in your scientific career, but maybe if you want to consider other careers. Okay, that job ad is getting older and older every year. There's many like it every month. Okay. The next, Eastman at the top. You know, when you apply for a position or you apply to medical school or anything, or maybe a scholarship, they're going to want to have a letter of recommendation about you and an evaluation of you. Most of the time, they're not going to say, how well does Susie understand SN2 chemistry? They're not going to ask that. They're going to ask things like, well, knowledge of field, that's it, you know, ability to apply knowledge, desire to learn, performance, creativity, self-expression, initiative. I like to write on there, ability to ask questions. I think that's important, okay? Keep that in mind. And, you know, that's what us professors are looking at all the time. Anyway, Santa Claus is always watching. All right? What's on the bag? Anybody want to fill Organic 2? I know nobody does. This is my sarcastic attempt to tell you some things to not do. Don't do these things. All right? Don't do those things. So that's the overview. You know, I could go on and on. Please read. Here's his first assignment. On Monday, our next class, I'll say any questions about the syllabus. Or you can ask before if there's a chance. But, okay? That will definitely be any questions about the syllabus. All right? Any questions at this point? Talk about organizing your material. For example, when you come to office hours, you need to be very organized. Okay? Please read the information about that. For example, writing your question down in a composition notebook. All right? You're studying one night, you got a couple of questions. Okay, it's time to finish up. Well, write it down. Okay? All right? I need to make sure I ask this question, or I need to make sure I do this, or I don't. Okay? Because the next day you're not going to remember that. It becomes a resource for you to help push you along. Okay? Another way to be organized, when you come to office hours, I like when you bring something like this, and a lot of times students listen to me and they come by and they'll have 5 things written here. And they'll say, okay, we'll talk about it, and then we'll move on to the next one. Other times I get students come by and they're like, well, I had a question, but I can't remember it. Okay? Anybody need a composition notebook? Sorry, I can get you one if you want. Stop by. Somebody else stop by. Also, Walmart has them. They're like 75 cents. A lot of reactions in Organic 2, way more than Organic 1. Okay? A good way to learn your reactions is write them on note cards. Just by writing out the note card, you're helping to organize and learn. But then you use it as a study aid, because maybe you'll leave something out. Okay? Or you ask some questions. And on the back, you put the answers. Okay? And a week later, you're reading it, and you got, okay, Stereochemistry, question mark. What type of stereochemistry do I need to know here? Oh, I forgot about this. Well, anybody need any note card? Way in the back. Although I think you already got something over there. Is that online? That's online. I think you already got a goodie.
Yeah, I got this.
I only get one goodie. Okay, so those are some suggestions. There's plenty more. We need to get going today. Any last questions? NMR. Magnetic, nuclear magnetic. We'll talk about that. Where shall we begin? Daily outline. Nomenclature. Okay. Green sheet. Chemistry of alcohols and ethers. Alcohols and ethers. How do you name alcohols? Okay, while we got the green sheet in our hand, let me just give you an overview of the chemistry, then we'll look at nomenclature. Very important chemistry of alcohol. What type of chemistry can we do? We can do substitution. We can replace the OH with a nucleophile. Hopefully that looks very familiar. You did some of that with SN2 substitution reactions. Substitution reaction. We can do elimination, make like alkenes. It's a common route to alkenes. We can maybe put an alkyl group on the oxygen, and now it's an ether. A lot of this will be reviewed from Organic 1, especially if you had me. Okay. New. Well, you can oxidize alcohols to the carbonyl compound. It's still carbon, 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 O, carbon, 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 O. We just lost H's, and now we have some unsaturation here. Okay. And further oxidation is possible. I try to give you outlines to help you be organized. But you need to do even more to be organized. This helps me because I know what I'm doing, where we're going. We'll then move to the chemistry of ethers and epoxides, and then down the road on the flip side. This is largely the chemistry for test 1, in addition to NMR. Okay. But first, let's look at the white sheet. On the front of the white sheet is my idea of a warm-up. Dr. Hogger does more involved warm-ups. Question? Which one? What color is that?
Better students. We have some extras right here.
The one with the drug on the front, bottle of the drug. Anybody else not get that one? Okay, good. This one here? Okay, my idea of a warm-up is to give you some interesting kind of application. Okay? Why is this stuff interesting? Why is it important? All right? Now, I noticed that this is actually one that I have also started using in Organic 1, so you guys may have seen this, but it's applicable here, and there may be some different language more towards Organic 2. Clindamycin is a common antibiotic used in the hospital setting a lot. And so what's going on here? Not only what's going on here, how would you accomplish this conversion? What's going on here is right here. This OH is being substituted with a chlorine. That's the only thing going on here. Again, I'm not going to read the whole thing to you. Take a look at it. There's often questions here. Very often the questions may be sort of advanced to make you sort of wonder and struggle and, I don't know. Well, the idea is, hopefully by the time we're through with the chemistry, then you'll be able to more quickly say, okay, I can do that. Sort of just setting the stage and showing where we're going. Same on the back. There's a very interesting mechanism over there. It's actually a little bit challenging. So, I'll often give you these warm-up pages to sort of illustrate where we're going and show some, what I hope you find interesting things. Let's begin with nomenclature of alcohols and ethers. Y'all ready? Ready? Okay. Well, of course, alcohols. You got your type of carbon group. Okay. OH. Nothing new there. The carbon group is typically an sp3 carbon. And we typically call those types of alcohols like aliphatic or saturated alcohols. Okay. These three are examples of aliphatic saturated alcohols. The carbon is sp3 and okay. Now you can also have R being an aromatic ring, for example here, aromatic ring OH. Well, this we know as phenol, and it's OL, not YL. If you say phenol, that is the radical term for benzene ring. It's phenol, OL, 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 alcohol, OL. Okay. This is an enol, because it's an OH on an alkene. Enol. We actually saw these in Organic 1. When you hydrate an alkyne, you first get the enol, and then it undergoes a process called automerization to give a carbonyl compound. But we'll revisit that, and we'll see enol. The enols are usually not stable. Usually not. Although the coffee sheet has an enol. Where's it at? I didn't pass that one out, did I? I've already hit it. There it is. There's an enol down there. Look right here. What is that? It's got an enol in the structure. Why are they drawing it like that? Some enols are stable. Not the whole compound, but just that particular tautomer is preferred. The enol tautomer is preferred. Why? Well, that's test 4. That's down the road. Come March and April. Okay. Nomenclature. Nomenclature is all pretty standard, follows the same trends. It's as with alkanes, but we're going to identify the longest continuous chain. What's the longest continuous chain? Carbon chain. Carbon chain. 1, 2, 3, 4. The heteroatom is not part of your parent chain. 4. So we're dealing with like butane. That's your prefix, right? We replace the E of butane with OL. So instead of E, we get rid of the E and we put OL. This denotes that there is an OH group. What do we call an OH group? Alcohol. Hydroxyl, not hydroxide. Hydroxide is the anion. That's not an OH anion. Hydroxyl. That indicates that there's a hydroxyl on the butane, so it's called butanol. All right, and that's how this is done. And we'll see this trend in many other functional groups. Well, if that's butanol, what is this? 1, 2, 3, 4. It's a 4-carbon chain with an OH. That's also butanol, right? But these are isomers, constitutional isomers. How do we denote between these two? We need to indicate where the OH is at. Where's the OH here? The 1 position, okay? Numbering begins with N nearest the OH. So, which end is nearest the OH? Duh. That one. So that's 1, 2, 3, 4. The OH is on the 1 position. We say 1 butanol. This indicates where the OH is at. What do you want to call this guy? 2 butanol. Question, is there anything such as 3 butanol? Why not? What if I put the OH here? That's just that, just around. Okay? No such thing as 3 butanol. All right. Now, this one actually has potential for having enantiomers, right? Because you got a chiral carbon. And so you could have R2-butanol or you could have S2-butanol, right? Subs get lowest numbers. We need to remember that. So, name this compound here. Longest continuous chain. 1, 2, 3, 4. Either way you go, 5. Okay? So I'm going to circle it. And either way you go, I can circle there or here. 1, 2, 3, 4, 5. What is that? Okay. We got an OH. This is an alcohol, so we name it like this. Okay. We got to denote where is the OH? 2. Because we're going to say which end wants to be the one position? Here, nearest the OH. So that becomes 2. 3, 4, 5. Well, what else is here? We also have a methyl. What position is it at? 2. Also at the 2. So we have 2-methyl 2-pentanol. Typically dashes between your numbers. Now, stereochemistry? Well, there's no stereochemistry shown, so you wouldn't be able to address it anyway. But there's no chirocarbon. That's it. That's an unambiguous name. If you were shown this name, you should be able to thus also draw that structure. Go the other way. Questions? There should be other alcohol nomenclature in your textbook. Oh, this guy down here, what do you want to call it? Well, if that was just an alkane, what would you call it? Cyclohexane. Yeah. But we're going to replace the E with what? Oh, well. That's what we said up here. Trust what we said and apply it. Cyclohexanol. Well, that's cyclohexanol right there. Now, in a ring, the one position, what's the one position? It's actually right here, because you can start anywhere, and okay, since we want that to be the lowest, well, you call that 1. That'll make it the lowest. Now, since that's 1, where's the chlorine? 3. Why not 5? Go this way, because subs get lowest numbers. So that's 3. So we have 3 chloro. That's going to all be all one word there. 3-chlorocyclohexanol. And do we need to say 1 somewhere? Actually, no. By definition, by default, we know the OH is at the 1 position. Because really what you have here is you have cyclohexanol, that's it. So there's your cyclohexanol, and then you say, well, I'm going to put a 3-chloro on it.
So the hydroxyl group is straight
This is, we're naming this as an alcohol. We're naming it as an alcohol, and typically, that's a good question. We'll see. The other way to name this would be to name it like an alkane, and you can name it, that way you would call it 1-chloro-3-hydroxy cyclohexane. This is naming it as an alkane and just calling these substituents. And why not call chlorine 1? Only because of what? Alphabetical. Okay? We're learning how to name it as an alcohol. But that's a valid name. Typically, these would be named as an alcohol. And that's a hydroxy group. So this is naming it as the alcohol as a substituent. You see how I asked a question that allowed us to get to a point, and I think it's very valuable. Okay? I wouldn't have shown that if you hadn't asked the questions. Now, it took 15 more seconds. But thank you for the question. Okay. While we're at it, let's go ahead and look at nomenclature of ethers. course, ethers are where the oxygen has two R groups. There's no OH. The R groups can be either sp3 or sp2. Even that alkene, and it's still an ether, and it'll be very stable and common. One of the most common ethers is diethyl ether, right here. Oh, by the way, I forgot to point something out on the previous page. Because I alluded to it, but then skipped it. The idea of types of alcohols. The OH is on a primary carbon, primary alcohol. OH is on secondary alcohol. OH on tertiary carbon, tertiary alcohol. So classification of your alcohols. Also, some compounds go by sort of common or slang names, like this guy here, isopropanol. That's a slang name. That's also a slang name. This is the only official name. 2 carbons, OH. Why do we not need to say 1 ethanol? Because there's no such thing as 2 ethanol. These are slang names. What's the official name of this? IUPAC. Instead of isopropanol. Two propanol? 2 propanol? You should be able to name that just like we did. That's 2 propanol. Longest continuous chain, and then where's the OH? Okay. So classification of your alcohols is important. We'll actually look at a chemical test to distinguish between primary, secondary, tertiary alcohols. Ethers. Okay, 2 types of ethers. Symmetrical, where the R groups are the same, and non-symmetrical, where the R groups are different. Diethyl ether is a common solvent in the lab. Okay, pretty low boiling. Used to be used like in the Civil War era to knock people out for surgery and stuff, anesthesia. Talk about a headache. This guy used to be MTBE, although the initials aren't even right, if you do the name. Used to be used as a gasoline additive to get more oxygen in the gasoline. But it's been phased out, and now instead of putting that in gasoline, you put ethanol in gasoline. Up to 10%, according to my gas pump. Right? Because if you get some oxygen into the mix, it helps the hydrocarbon burn better. Okay, you can also have cyclic ethers where the oxygen is part of the ring. You can't have an OH with the O being part of the ring. You can with the ether. So this is a 5-membered ring with one of the atoms being oxygen. That's called THF. That's a common solvent. Okay. Any of these you can find on Wikipedia. Just say THF and it will give you a whole bit about it. Very common solvent, although it's not used too much at the undergraduate level. Because there's others that are cheaper and better properties, a little bit better. That one has good properties at the advanced level. Nomenclature of ethers. Pretty darn simple, and actually there's your nomenclature right there. You just name the 2 alkyl groups, and then you add the word ether. Now, if the 2 alkyl groups are the same, you can just say di. 2 ethyl, so diethyl, and then the word ether. How would you name the one on the right? Something, something, ether. What are the 2 somethings? Methyl. And this is going to be 3 words. What is this group over here? Now, most of the time this goes by slang. What is sort of the common name for that group? Tert-butyl, or T-butyl. Because it's a butyl group, 1, 2, 3, 4, but the carbon is tertiary, the carbon that the other stuff is connected to. So if we say methyl, butyl, and then what's the third word? Ether. These are the two things connected, ether. MTBE. MTBE. Problem is, you want to list these in alphabetical order. And probably some news journalist person came up with this originally or something, I don't know. Because it's not right. These italics like tert and sec don't apply to your alphabetical. This is really M and B should come first. Okay? Because you really are looking at the B to determine alphabetical. That's okay though. THF is a common name. We're not going to look at cyclic ethers. Let's see if we can name down here. How about this guy? Actually, what I want to do more of is to have you do these, and then we look at it next time. That one, I'll do the others a little quicker because they take a little less time here. Our class time is very valuable. Okay. You can go do this anytime this weekend, Saturday morning, Saturday evening, whenever. Let's make sure it's done before class comes around. Let's do this real quick. What's on one side? That's a methyl. What's over here? It's a benzene ring. What do you call benzene ring when it's a substituent? Phenyl with a YL. Okay? M and phenyl. M comes first, so it's methyl, phenyl, ether. All right, well, nobody calls it that. That's got a common name. It's called anisole. All right, there's lots of common names. I would never expect you to really know the common names unless I tell you to. What we're learning is systematic, official nomenclature. Okay? But that reminds me, when we get to aromatics, I'll give you about 7 common names I want you to learn, and anisole will be one of them then. Okay? When we look at aromatics specifically. What do you want to call this guy? No, I'm not even going to write it down. It's the same, so it's di what? Dicyclopentyl ether. Makes sense, right? Dicyclopentyl ether. Okay. We'll begin the chemistry. And Roman numeral 1, substitution reactions. That's the same reaction on the green sheet. It's a substitution reaction. So that's what we're going to do first. And after that, we'll do elimination. So it's sort of organized here. And here we go. OH is a poor leaving group, right? For leaving in rate determining steps. That'll be important later on. But the substitution mechanisms you know, SN1 and SN2, the leaving group leaves in the rate determining step in both of those mechanisms. So OH is a poor leaving group for those mechanisms. How do you make OH a better leaving group? Protonate it with strong acid, right? Like I said, this is going to be a good amount of review, but we'll have new stuff here as well. Reaction, the first reaction we'll look at is reaction with HX to give what? Now for you guys who've not had me before, please realize that I organized this to be very helpful and informative. And each word you need to take serious. So for example, when you react alcohols with HX, what type of product does it give? Halides. Don't just read the heading and gloss over it. Read the heading and say, okay, what is here? What are we doing here? Because terminology is very important because that helps organize your thoughts, among other things. Okay. Now you can use, you got to be careful about your nucleophile. I make some general comments here. Okay. We may refer back to them after we get going. Nucleophilic strength. Reaction can be either SN1 or SN2. If it's a primary alcohol, it's always going to be SN2. That makes sense, right? Because you never make a primary carbocation. Okay? So it's all some just things that I think are important. Let's do some examples. If you take, what is that, propanol? One propanol, because you could have two propanols. By the way, if one propanol, which means the OH is on the N, a lot of times these are called N normal or straight chain. Just where the OH is on the N. So a lot of times you may hear N propanol, but one propanol, reacted with HBr, you can get that. If you want to balance it, plus what? Plus water, right? Okay. Obviously a substitution reaction. Does it look like it's SN1 or SN2? SN2. Okay? Yeah. Mechanistically, what do we need to do first? Protonate the OH. Now, you can either keep this covalent, or you can just show it ionic. Okay? I may do both. If you keep it covalent, we just protonate by attacking here and kicking off the Br, right? Boom, 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 O. At this point, let me sort of make some suggestions. I see a lot of you guys not drawing out bonds. See, my OH is not drawn out. That's just because when you put it together, it's much easier and it takes a lot of time to draw it out. But have it drawn, particularly once you get going. Draw that H bond out. Now we got a new one. I see a lot of students protonate and I mean, it looks like this. You can't work with it condensed like that. You need to be able to show your bonds so then you can start moving your bonds with mechanism arrows. Okay? One lone pair left. Now you gotta always be important to recognize charge. What's the charge here? Positive. Nothing new, right? Should be nothing new for my guys from organic 1. Hopefully it's nothing new for guys who do not have it. Can't see. What time? Okay. What's next? We got that Br minus. What are we going to do next? This is backside attack. Here, kick that off. What does that give? That over there. Gives that, right? There you go. Good old SN2. Questions about that? How about the one down here? I got some stereochemistry here. What type of alcohol is this? Primary, secondary, tertiary? Tertiary. Tertiary alcohol, HCl. Give that product. First off, what would be the stereochemistry here? What mechanism does this look like it should be? SN1. Why? Tertiary. Oh, you never do SN2 on a tertiary carbon? Right? Yeah, it's SN1. We can tell that for, since it's SN1, what stereochemistry do we expect for this chiral carbon? I didn't hear you, but did anybody say racemic? It'll be racemic, that's the SN1 outcome. Okay? Now do your mechanism. All right, well in there, please, there's I think 2 others here. The last one says for homework, basically do 2 or 3 for homework, all those in that section. But more than that, please look ahead. Because importantly, if you haven't looked ahead, you're not going to be prepared to learn from the lecture. You should even come with questions about material that's ahead. Okay, guys, have a wonderful weekend. Look for emails from me.